Hey guys, it's Josh Levy and Morgan Guess, and this is our Project 6. This program allows you to input different locations in the U.S., and the code creates routes based on those coordinates closer to the cities and towns put in. The highway networks are used to find the shortest route by the underlying graph and show that route. The code asks where you want to leave from and where you want to go. It will calculate the shortest path based off those coordinates and now visualize that path based on the highway system in the U.S. On this code, you can see the coordinates are printed, the closest vertices possible based on highway routes, and then compares those two and gives the mileage of the distance between these two coordinates. Furthermore, the code measures how long it took to calculate the coordinates, calculate the shortest path route, and calculate the distance and mileage.
For this demo, we constructed a user interface using JFrame, specifically the grid bag constraints for formatting, and we were able to add a little button that says calculate on it, and a text entry box for the start, text entry box for the end, and then text boxes displaying on the left distance and on the right runtime. So as you can see, if I try to input something that is not in fact a valid city and state and doesn't belong in our map, then it will tell us invalid input. If the string that I've entered is in fact valid and it represents a city in the map of all of the cities and corresponding points, then it will run the nearest point method on these cities and find the nearest point in our grid and output that to the terminal on the right-hand side. When Route Finder's calculated the actual route and the distance of that route, it outputs that as well to the terminal, and it draws the shortest path from the starting point to the ending point, and then displays in the terminal the total time that it took to get the nearest point, the route, and the distance. As you can see, the runtime of our code is not the most optimal. I think that this was affected by the speed of my computer. It's very old, and unfortunately, it's not the best, but we were able to implement a couple of features that reduce the runtime. Rather than using Dijkstra's algorithm, we implemented an A-star search that implements a heuristic function to estimate the remaining cost of reaching the final node where we're trying to travel to. And I think that reduced the runtime by a decent bit. And for our distance calculation, we used union find instead, as per the optional instructions on the GitHub. As you can see, the code is able to complete successive routes and add them to the map, and so you can keep track of different routes you've taken, little journeys you've made. And that's it for our project. This was Josh Levy and Morgan Guess. Thanks.